Video on Chapter 5, working with quadratics. A quadratic equation is any equation where a variable is being squared. Usually it's when the x is being squared. So y equals x squared we'd call it quadratic. And one thing we can do with quadratics is graph them by plugging in some numbers. If I plug -3 in for x, -3 squared is +9, so that becomes a 9. You can see the point -3, 9 just graphed. If I plug in a -2, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. This is something you've probably seen before. It's called a parabola. A parabola is a curve that has two very important properties. One is that it's perfectly symmetric. If I were to draw this, the only thing about this y-axis is a mirror, this half of the graph reflects to this half of the graph. Every parabola is symmetric, and it's always symmetric through the vertex. The vertex is the highest or lowest point, in this case the lowest point. And so the line going through the vertex is the line of symmetry for the parabola. So we can graph equations from standard form. Standard form is when you have y equals ax squared plus bx plus c, where a, b, and c stand for some numbers. So like in this case down here, my a value is 1, grab a smaller pen. A value is 1, b value is 4, c value is 3. One way to graph this is by making a table like we just did, plugging the numbers from -3 to 3. So if I do that, I can -3 here. -3 squared is 9, minus 12 is -3, plus 3 is 0. This is the point -3, 0. Plug in -2, -2 squared is 4, minus 8 is -4, plus 3 is -1. Plugging in -1, -1 squared is 1, plus 4, minus 4 is -3, plus 3 is 0. Plug in a 0, 0 squared is 0, plus 4 is 0, plus 3 is 3. Plug in a 1 squared is 1, plus 4 is 5, plus 3 is 8. 2, 4, 12, 15, 3, 9 plus 12 is 21, plus 3 is 24. So I have the points -3, 0, -2, -1, -1, 0, 0, 3, 1, 8, and I really can't put that on my graph very well. And what's nice about this curve I've got is I've already got this half of the parabola. So I know that this half over here is symmetric, so I can take this point right here and go boom, 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 and copy it over. I'll take this point up here and copy it over, and get my symmetric looking parabola. The problem with using a table to graph is you don't always know where the vertex is going to be. So plugging in numbers from -3 to 3 like this is pretty rarely the best strategy. It can sometimes work if you're in a jam, where you can tell it's going to be, around that area. But generally, you don't want to just plug in -3 to 3. So I'm actually going to skip this one and ask two quick questions before we move on. Do you remember how to graph the line x equals -2? Go to pause and think about that for a second. You can. The line x equals -2 is a vertical line through the x-axis at -2. If it was y equals -2, it would be horizontal, but x equals -2 is vertical. It's an important thing for this chapter. Another thing, where is it? Here. If I have f of x equals 2x squared minus 3x plus 1, if I wanted to find f of -4, I'd plug in -4 in for x. I get 2 times 16, so you do -4 squared, you get 16 first, plus 12 plus 1, which is 32, plus 12 is 44, plus 1 is 45. And if I did f of canoe, that would be 2 canoe squared minus 3 canoe plus 1. Those are two review things. They'll be important for this next couple slides, actually. Standard form of a parabola, y equals ax squared plus bx plus c, tells us some things that we can find very quickly just by knowing stuff about the formula. For example, this value c, which will stand for some number, is always going to be the y-intercept. So right now, this point right here is my y-intercept. It's at the point 0c. In this case, c would be -3. You always find the y-intercept by looking at this c value right here. Another very useful thing, in fact, this is probably the most useful thing, is the axis of symmetry, which is this orange line right here. I'll change colors. This orange line right here is called my AOS, axis of symmetry. That's the line that cuts the parabola in half, makes it symmetric. Can be found using this equation, x equals negative b over 2a. If I take whatever this b value is and divide it by 2 times that a value and make it negative, I can find the vertical line that cuts the graph in half. Then, here's the part that most people kind of struggle to understand. If I take whatever that value is, if I take this number right here, and I do f of that number, if I plug that number in for this x here, and for this x here, I can calculate the exact point of the vertex. I can find the vertex by plugging this value in to the equation for x. And finally, if this a value is positive, the graph points up, smiles. And if this a value is negative, the graph points down, and it frowns. So we'll do a couple quick examples of this to explain how it works, and then I'll turn you loose. I'm going to graph the equation y equals x squared minus 6x plus 5. And my a value is 1, my b value is negative 6, my c value is 5. First thing I'm going to do is find the y-intercept, which is at the point 0, c, which in this case is going to be 0, 5. That's my y-intercept. Then I'm going to find the axis of symmetry, so I do x equals negative b over 2a. Well, in this case, negative b is negative 6, so negative b is positive 6. 2 times a would be 2 times 1, and I come out with a 3. So I have a vertical line at 3. Let's get a light faint color. 1, 2, 3. And this is the line that's going to cut my parabola in half. My parabola is going to be symmetric about that line. One thing nice about that is I know that this point over here can get reflected. I go 1, 2, 3 spaces, 1, 2, 3 spaces, so I go 1, 2, 3. There's another point on my graph because of that symmetry. Once I have half the points, I have the other half. If I take this 3 and get it to a regular pen, it's not going to be dotting. If I take this 3 and I do f of 3, if I plug 3 in here and here, I get 9 minus 18 plus 5, which is negative 4. 1, 2, 3, 4. That's my vertex. The point 3, negative 4 is my vertex. Now at this point, I can just start plugging in some other points. And now that I know where the AOS is, and now that I know where the vertex is, I can plug in points around 3. So I've plugged in 3, I might as well plug in like 2 and 4, or 1 and 5, and see what that comes out with. So if I plug in a 2 for x, I get 4 minus 12 is negative 8, plus 5 is negative 3. So this point is 2, negative 3. And I can go to the symmetric point over here at 2, negative 3. And really at this point, I've probably got enough points to make a good graph. I've said the word point a lot. I'll do one more, just because I might as well do this accurately. But these 1, 2, 3, 4, 5 points I've graphed make a very nice parabola. If I plug in a 1 for x, I get 1 minus 6 is negative 5 plus 5 is 0. So I have those 2 points there, because I can do the symmetric point. I start with this point, then I go symmetric over here. My parabola looks like this. Make your parabolas U's, not V's. My parabola wasn't perfect, but you kind of get the idea. Make them U's, not V's. In fact, let me draw a perfect one. My computer program, I think I can do that for me pretty well. And not quite. I can't get that to go through those points the way that I want it to. I'm going to have to get rid of that. Last thing that's worth discussing. Oh gosh, I totally missed that point when I graphed it. I might try that again. There we go. No. Here. This. Here. This shouldn't happen. The way that it's kind of bowing out like this, that shouldn't happen in your parabolas. I'm going to live with this for now because I want to move on. This point right here, where you cross the x-axis, this point here and this point here that we'll pretend like I hit. These are called x-intercepts, or they're called roots, or they're called zeros. All three of those terms can be used. They are very, very important, so make a note of those. One more example. I'm going to graph this one. My A value is -2, my B value is 6, my C value is -4. I'm going to start by doing negative B over 2A. This is where I like to start. You can always start by finding the y-intercept. I know that's -4, so I guess I've got that covered. This right here is my y-intercept. I'm going to do negative B over 2A, which is going to be -6 over -2 times 2, which is 6 over 4, which is 1.5. Not a whole number, but that's okay. Here, still on my parabola. During class, you would fix that for me. We'll go red. Here is my axis of symmetry. That line right there, that's the line that's going to cut my graph in half. Now I'm going to take this number, so I'm hitting so many buttons here, take this number right here and plug it in for x. So I'm going to do f of 1.5, I'm doing -2 times 1.5 squared plus 6 times 1.5 minus 4. And I think I'm going to do that in my calculator. You sure can too. -2 times 1.5 squared plus 6 times 1.5 minus 4. Get out 0.5. Point 1.5 comma 0.5. That's my vertex. Right there in the middle of that square. Now here's a huge, huge trick that is so important to remember, although not necessary. This A value I call the first step. And it's only the first step from the vertex. Here's what that means. Since this is a -2, from the vertex right here, I can think about it like a slope. You go down 2, right 1, and down 2, left 1. The first step is always going to be whatever this A value is from your vertex, but only the first step. The next one isn't down 2, left 1, down 2, right 1, because the next step, that would make it linear. It's not linear. I've actually got these points here now. I've got this point, and I can reflect it over 1.5, 1.5. I've got these points and these points. And with those 5 points, I can draw a decent, although narrow, parabola. So remembering that thing about the first step from the A value can make graphing very quick. In this problem, I really only had to plug in one number. Thanks for being patient.